Bismillah, Alhamdulillah, Assalatu wassalamu ala Rasulillah, sallallahu alayhi wasallam. Allahumma salli wa sallim wa barik ala Nabiyyina Muhammad, sallallahu alayhi wasallam. Assalamu alaikum. I would like to welcome all of you in this class session of Power Plant Engineering. And Alhamdulillah, this is the last class session from my end. And today I will be talking about, inshallah, thermal power plants, actual ones. We had 3 class sessions related to thermal power plants. Now these are all idealistic, yeah, basic Rankine cycle, reheat Rankine cycle, regenerative. Today we'll talk about the actual ones. The actual ones are basically combination of reheat and regenerative. It's a combination. So we'll try to explore some of the state-of-the-art technologies. Also, inshallah, we'll have case studies from Bangladesh as well. Some of the new power plants which are coming up. We'll try to briefly discuss or highlight some of those, inshallah. Learning outcomes. So hopefully, after participating in this class session and studying the related contents on the accompanying online course site, and in Google Classroom, I'm sharing many useful resources, recording of previous class sessions. You are recommended to go through those materials to gain insights or more deeper understanding about these things which I'm trying to cover in the class sessions. You need to go through those materials as well. So fully, you'll be expected to explain actual thermal power plants operating on modified reheat regenerative Rankine cycle. Yeah. Modified reheat regenerative Rankine cycles. In reality, you have that nowadays. To explain subcritical, supercritical, ultra supercritical, and advanced ultra supercritical coal-fired thermal power plants. So these are some of the new technologies. These are, for example, this ultra supercritical. It's according to IEA, International Energy Agency. It belongs to a category called HELE technologies. High efficiency, low emission technologies. High efficiency, low emission technologies. And supercritical, ultra supercritical. Already we have that at Matarbari. Yeah. So they're quite good better than the subcritical, which we have already, supercritical or ultra supercritical. And in the future, I will try to discuss about that. In the future, this is coming up. Already I saw a brochure from GE, General Electric, that they have started this advanced ultra supercritical type power plant. So try to discuss them, inshallah. Then discuss the main coal-fired thermal power plants operating in Bangladesh, and I'll try to give you, discuss their performance even day before yesterday. So I have downloaded data from PGCB's website, and I will show you how these coal-fired power plants are operating even day before yesterday. We'll try to talk about that, inshallah. And list the commercial boiler and steam turbine technologies. So you saw in Cengel, and you solved problems. You are seeing certain operating features. We solved a problem where let's say pressure was, it's a 10 MPa. Yeah, pressure was 10 MPa. But in reality, what is the pressure in today's world? We'll try to see. Also, finally, we want to look what are the emerging technologies which are coming up in the coming days. This is important for you to know the state of the art technology, so that in the coming days, if you go for an interview, if they ask you what are the trendy technologies or what are the emerging technologies, you are in a position to answer, inshallah. So with these lofty goals, lofty learning outcomes, we'll start the session, and very quickly we'll have a quick review session. Yeah, things you have learned from the previous class session. Who wants to share? Yeah, Akhtar, very quickly. Akhtar, yeah.
So we learned about the working mechanism of an ideal regenerative Rankine cycle.
Okay, ideal regenerative Rankine cycle. Yeah. What's the benefit of this ideal regenerative Rankine cycle, Akhtar?
Sir, the benefit is that the feed water is preheated with the steam that is extracted from the turbine, so it increases the efficiency of the cycle as well as decreases the fuel cost.
Excellent. So it increases basically the TH. So your efficiency, thermal efficiency, is supposed to increase. Yes, Jannat.
We learned about deaerators and types of deaerators.
Deaerators. Yeah, very important thing. It's important for you. Yeah, Abdul Noor.
So we learned about the main advantage we can get from closed type feed water heater.
Okay, closed feed water heater. Closed feed water heater. You know, there are two types, open and closed. So he is saying about what's that advantage, Abdul Noor?
So the advantage is we can maintain pressure in closed feed water heater.
Maintain pressure. It will be inside the tube. Yeah. Okay. Thank you, Nabil.
So two types of deaerator, spray type and tray type.
Yeah, two types. One is spray type and another one is tray type. We discussed those two types of deaerators. Excellent. Anything else? Any other things you can recall? Yeah, Mubashir.
Sir, we learned about a new website called Savory to know about our subject more precisely through videos.
What is that? Which one?
Sir, SAVREE. Sir, you said about this website.
SAVREE. Yeah, they are preparing some nice contents, and I showed you. Yeah, it's very, very useful. Yes. Okay. REE. Yeah, I've forgotten the.
Yes, sir. REE.
I've forgotten that. It is quite unusual acronym or what, I don't know. Okay, thank you very much. Yes. Nabil, you have anything else to add?
So in real life applications, we use 4 types of turbine.
4 types of
turbine.
What are these?
High pressure, then intermediate pressure, and 2 low pressure turbine.
Very good. So what he's saying, though in your Cengel book, you saw for the reheat cycle, there are 2 turbines, high pressure and low pressure, but in reality, and today you'll see, today we'll try to see some actual thermal power plants. We'll try to investigate a 300 megawatt, 500 megawatt, and 1000 megawatt units. And you will see, I mean, most of the time, I mean, you'll have 1 HP, high pressure, one intermediate pressure, and 2 LP. This is the way they are coming up nowadays in most of the cases. Yeah, so you should be aware of that fact. Okay, any other thing? Okay, let's move on. Let's move on. Very quickly, what we studied before, we started with the basic Rankine cycle. Yeah, basic Rankine cycle, and which is quite simple, but it has issues with efficiency. And of course, a real cycle will deviate. There will be pressure drops, and you cannot have isentropic processes. So you'll have increase in entropy. So those things are there. Then we studied the ideal reheat Rankine cycle. Ideal reheat cycle, because yeah, we want to benefit from the increased boiler pressure. At the same time, we don't want to suffer due to the higher amount of moisture content. So that's why this is a common trend. Always nowadays in modern thermal power plants, you'll have reheaters. So after the high pressure turbine, steam will be taken back to the boiler in the reheat section. It will be reheated. So more energy will be added, heat will be added, then it will be taken back to another turbine. In this case, in this figure taken from Cengel, you are seeing low pressure. It's taken to low pressure turbine, but in reality, it will be taken to intermediate pressure turbine. And then from intermediate, it will go to low pressure. So this is what happens in reality. And we talked about the ideal regenerative Rankine cycle, where you have regenerative heaters. Yeah, these are regenerative heaters. There you have closed type and you have open type. Somebody mentioned in the case of closed type, you can maintain the pressure because your condensate or feed water will be inside the tube. And in the case of open type, there is one benefit. You can transform that into a deaerator, yeah, to get rid of something. What's the point of deaerating? Who can tell me why we are deaerating, by the way? Yeah, Abdul Nur, Joy.
So to remove the dissolved oxygen and carbon dioxide.
Yeah, to get rid of the dissolved oxygen and CO2. Okay, if we allow them to remain in the feed water, what will be the consequence, Tanjid?
So corrosion will be occurred if we keep
corrosion. Yes, so the deaerating is very important. And usually what happens, again, from today you will see that usually these are known as blade steams, yeah, or these are extracted steams. They come from different turbines, come from high pressure or intermediate pressure turbines, and based on that you will have low pressure feed water heaters and low pressure feed water heaters and high pressure feed water heaters. That's from the actual plants what we have. Okay, there is a virtual tour today. One of you mentioned, yeah, from that website. Yes, you can visit that website. How coal-fired thermal power stations work. You will see. I mean, step by step fashion. They will show you what's happening in the actual coal-fired power plants. Let us visit this website.
Hi, John here. In this video, we're going to be looking at a coal-fired power station. I'm going to show you all of the systems that make up a coal-fired power station and how they work.
Let me see whether you can recognize some of these things. Yeah, this is from reality. I mean, what you usually see. Yeah. What is this thing? Yes, Jannat.
Cooling tower.
Cooling tower. Thank you very much. Okay. Now, boiler is coming. What is this thing? This one. Sam.
So steam turbine.
No, steam turbine, but there are several steam turbines. Yeah, you are correct, steam turbine, but I want more details. Akhtar,
Sir, high pressure steam turbine.
this is the high pressure. I was telling you a while ago, high pressure steam turbine. What about this one? What is this? Subho.
Sir,
Sir, low pressure, sorry, intermediate pressure
This
turbine.
is intermediate pressure, IP turbine, HP turbine, IP turbine. What about these two, Arnob?
Sir, low pressure steam
Low
turbine.
pressure steam turbine. And what about this thing, what you are seeing here? What is this thing? Yeah, Shubho.
Sir, it's a boiler.
It's a boiler. Yeah, it's a boiler. Okay, can you guess what is this? What is this? Any idea? Yeah, Mubashir.
Sir, deaerator.
Deaerator. Excellent, excellent. Yeah. Now another question. What is this thing? Sam.
Heat exchanger.
Yeah, heat exchanger, but what is it called in a power plant? Yeah, Fahim. Fahim, I can't hear you. Tell me again. No, incorrect. Tanjeed.
Sir, mixing chamber, sir.
No, Akhtar.
so condenser.
Condenser. Condenser. Yeah, so this thing is getting something from the cooling tower, which we say is CCW usually. What is this CCW? Fahim, can you answer that? Joy.
Sir, is it an economizer?
No. This is condenser, but it is getting something here. It's called circulating cooling water.
Yes.
Circulating cooling water. Okay. Okay, let's continue.
Sir, then where is the economizer located, sir?
Now, economizer will be somewhere here in the boiler. Economizer will be in the boiler. And in the boiler, economizer basically it preheats the water before even the water goes to the boiler drum. It's kind of preheated, and you can preheat with the help of several things, including flue gas. So economizer is related to boiler. Yeah, it's usually typically it will be inside the boiler, and there are other illustrations where you can see that. Here it's not clearly shown, but you will see it. You will see it. I think even in this one they will show it.
Work together in order that a coal-fired power station can generate electricity. By the end of the video, you'll know all of the major systems that we require in order that I'm going to show you all of the systems that make up a coal-fired power station and how they work together in order that a coal-fired power station.
Yeah, 16 is economizer. 16. Yeah, where is 16? Yeah, here. See, this is here. This is economizer inside the boiler. In fact, before it goes to the boiler drum, it should go to the economizer. And I think he'll mention.
Can generate electricity. By the end of the video, you'll know all of the major systems that we require in order that a coal-fired power station can function correctly. We'll cover the fuel system, the water system, the steam system, the electrical system, and also the exhaust gas system as well. So by the end of the video, you really will know exactly how a coal-fired power station works. So let's get started with an overview of a power station and its main systems. I say main systems because there are a lot of systems that make up a coal-fired power station. They all work together to produce electricity, but you have major and minor systems, and we're looking at the major systems. The first thing we're going to need when we build a coal-fired power station is coal. The idea is that we burn fuel to release chemical energy that we can use to heat up water and create steam. So we can see we've got a ship on the left-hand side of this diagram. The ship is delivering coal. We will unload the coal from the ship, and then we'll use a stacker to stack the coal up in a coal yard or perhaps a coal dome, or generally just a storage area.
Now, when you get coal in a coal-fired power plant, by the way, just to motivate you, today our focus will be, we'll see mostly on coal-fired power plants, not thermal power, coal-fired thermal power plants, not on, thermal power plants operating with the help of gas or liquid fuel. Is there any rationale for that, especially from Bangladesh perspective? Is there any rationale? Why knowing more about coal-fired thermal power plant is more important in today's world? Who can tell me? Why I'm not focusing on liquid or gaseous fuels here when we are studying thermal power plants? Yes, Fairuz.
Resource availability.
Resource availability. We are importing coal. Today I will show you some of the coal-fired power plants are not operating due to shortage of coal. So we are importing coal mostly. Boropukuria was mine mouth power plant, but other coal-fired power plants are mainly based on imported coal. Now, today is the last class session. Just think about it from efficiency perspective. If you have choices, now you have different types of power plants. You have, let's say in Bangladesh, mostly we have gas. So when you have natural gas, what is the rational choice? What is the rational choice? Thermal power plant, gas turbine power plant, or combined cycle power plant, or diesel or reciprocating power plant? Which one you will be selecting when you have natural gas? And why?
Gas power plants, because it is available in here.
Oh, no. I'm asking you which technology you will be selecting. Which technology you will be selecting when you have natural gas? So you have different options. As I said, you can go for gas turbine power plant, you can go for combined cycle, you can go for thermal power plant, you can go for reciprocating type. Which one you will select and why? Sadman.
Sir, I will choose the combined cycle power plant because
Yes.
I have done an attachment to the Shirazganj power plant, and I have seen it there that they use the combined cycle power plant and using.
No, but why?
gas
Yeah, correct. But
So-
why combined cycle?
Sir, to use the gas to run the Brayton cycle and then use the Rankine cycle with steam, the heated
But
steam.
my question is why you will select combined cycle? Mubashir.
So efficiency high is very high than the others.
Exactly, that's the reason. Efficiency. When you compare the efficiency of combined cycle with the efficiency of thermal power plant, then you will understand why you are using combined cycle power plants. What will be the typical efficiency of normal coal-fired power plants or normal thermal power plants? What do you think? What is the efficiency range typical? Yes, Mubashir.
Sorry, around 40%.
Even 40 will be too high. Today we will see that efficiency range. The typical one will have 35, 36, something like this. Yeah. 40 will be maybe the highest or something like this. And what about combined cycle efficiency? What is the efficiency of combined cycles? Typical efficiency. Saim.
55 to 60.
55 to 60. Thank you, Saim.
Now we're going to be storing thousands and thousands of tons of coal in this area, so we've got to organize the coal yard or the storage area so we're not using up more space than we actually require. Once the coal has been stacked, we're going to need to reclaim it, and that essentially means that whereas we drop the coal off before into the...
Now you're getting coal, yeah? Let's say imported from Australia or Indonesia. What to do with this coal? Directly we'll send it to the boiler for combustion?
No, sir.
Raise your hand first. Sumaya, who answered that question? Yeah, Sumaya, yes.
No, sir.
So how it should be sent?
So we should first heat it. I mean, we should first so
It should be basically crashed.
yes, sir.
Crashed
Yes.
into powder. Crashed into powder. It's got pulverization. You will have to pulverize the coal. Then it will, and also preheat. Then it will go. Yeah, Fairuz.
So yeah, we should
We're not going to
refine.
coal up again.
What? Tell me again.
We should refine and reheat the coal so that the impurities are
Not
less.
reheat, heat up. Preheat. You can say preheat. Yeah.
And start feeding it towards the power station. The reason we have a coal yard in the first place is because sometimes we may not be able to get deliveries through to the power station, so they will store a lot of coal, sometimes enough for 3 or 4 months.
So this is a problematic aspect of coal-fired power plant. You'll have to keep, store it. There should be storage. Yeah, there should be storage. You want to keep coal for several days, yeah, or weeks, and it will occupy huge space. And it will be, if it is exposed, then you can understand what will happen.
And we'll gradually feed the coal then to the power station without having to worry that we're going to run out of coal. After we've reclaimed some of the coal from the coal yard, we'll send it to a silo, often termed a day silo, and we'll feed the coal from the day silo to a coal pulverizer. The idea of the pulverizer is that we can pulverize the coal in order to get very fine coal dust. Inside the pulverizer, we're also going to dry the coal out using air, called primary air, from a forced draft fan. We're going to take this air from a preheater so that the air is quite hot, and then we'll force it into the pulverizer, and as the coal is ground up into small molecules, we'll also dry it out using this air. We use the same air for combustion because...
So basically the hot air drawn with the help of forced draft fan, hot air will take it inside the boiler to the burner.
It's going to get blown into the boiler along with the coal. So we've got our coal dust leaving the pulverizer. It's being blown pneumatically from the pulverizer to the boiler. When we get to the boiler, we're going to ignite that coal and we're going to get combustion. So that is our fuel system. We may also use oil to fire the boiler, at least initially, or natural gas, which is predominantly methane gas. It all depends on the design of the boiler itself. The type of boiler we're using is a water tube boiler. Whenever you need a lot of steam at very high pressures, you're going to be using a water tube boiler. Steam turbines require steam at very high pressures, and that's why we use water tube boilers. But water tube boilers also generate a lot of steam. They're very large. They can be greater than 40, 50, 60 meters in height. And these are the boilers that power stations in the power generation industry always use. So let's have a look at our water circuit now, because it's water that gets fed to the boiler in order to generate steam. We've got a make-up water inlet. The make-up water feeds to a deaerator. When we talk about make-up water, we're essentially talking about the water that's added to the system and then treated before it becomes boiler feed water. You can't just take water from a city grid or from a lake or a river and put it into a water tube boiler. That's not going to work. You're going to have a lot of corrosion and a lot of problems. So this make-up water has to be treated chemically and mechanically, and we do that quite often in a deaerator. The deaerator is going to reduce the oxygen content.
So this is, I mean, you can see a deaerator here. It looks something like this, a big drum. Yeah, it's basically a heat exchanger.
And the CO2 content of the water. And before the water gets to the deaerator, it's going to be filtered, etc., to take out those particles that might be floating around in the water. Then we'll go to a boiler feed water pump. This is usually a multi-stage centrifugal pump, and we will increase the pressure.
This boiler feed water pump will consume significant amount of energy. Can be as high as 5% of power produced by the turbine. I mean, usually they're huge, pumps and require a tremendous amount of energy.
Pressure of our boiler feed water and send it to our water tube boiler. The pressures involved here are actually quite high. You're looking at in excess of 200 bar, which is in excess of around 3000 psi. The water will be pumped to an economizer where we'll preheat the water a little bit before we.
So somebody was asking earlier, economizer. Yeah, this is the function. I mean, you'll have to preheat the water before it goes to the boiler. And it happens in the economizer. Economizer, and also, as I was trying to say, it can also get heat from the flue gas before leaving through the chimney.
We send it to the main body of the water tube boiler. So the economizer is a nice way of preheating the water before we send it into the main part of the boiler to really start heating it up a lot more. We don't want to feed cold water into the main part of the boiler, or the furnace as we call it, because if we do that, then we're going to thermal shock the boiler, and that could mean that we have cracked pipe.
So this is showing that yellow circle is showing the location of the economizer inside the boiler,
etc. So we'll preheat it by sending it to the economizer. We'll then send the water around to the furnace, and we'll put the water into the water tube boiler walls. They're called walls because the piping around the furnace makes up a square space similar to having 4 separate walls. This means we can get a lot of heat transfer, mostly via radiation, to the furnace walls, and then this heat is going to be absorbed via conduction into the water, and our water is going to change to steam. We have different types of steam. We have wet steam and we have dry steam, superheated steam, etc. But when we talk about wet and dry steam, we're referring to if steam has water molecules in it or not. If the steam is totally dry, then it will have no water molecules in it. Steam is a colorless and odorless gas. And by the time this steam vapor has reached our steam drum, which is at the top of the boiler, we're going to have wet steam. It's not going to be completely dry yet. There's going to be particles of moisture in the steam. That is what we see normally when we think about steam. In the steam drum, we'll begin to separate that moisture from the steam, sometimes using steam separators or steam cyclones, sometimes using an arrangement of baffles or a combination of both. We'll then send our steam to a superheater where we will really heat that steam up, and although we get a slight.
As we discussed earlier, one of the ways to increase the efficiency of the basic Rankine cycle is to superheat the steam before it goes to the turbine. This is what you are seeing right now, superheating. Superheater is a kind of tubing arrangement inside the boiler.
At pressure drop, we're going to add more and more heat, and the temperature of the steam is going to increase. We will then feed that steam from our superheaters into a high pressure turbine. As the steam passes through the turbine, it causes the turbine runner to rotate. So we've taken the chemical energy of the fuel, turned it into heat, we've heated up the water, we've created high pressure steam, we've fed it to a turbine, and now we are converting that heat energy or heat into mechanical movement or kinetic energy. We're then going to take the steam out of the high pressure turbine. It's given up a bit of its heat already, but we send it back into the boiler to be reheated so that we can send it then to an intermediate turbine. The reason we reheat the steam is simply because we get a slight increase in efficiency, so it's definitely worth doing. But we feed that steam from the reheater in the water tube boiler to an intermediate pressure turbine. The process is the same as for the HP turbine or the high pressure turbine. We allow the steam to flow through the turbine rotor rotates, and then the steam exits the intermediate pressure turbine and is fed to two low pressure turbines. In the low pressure turbines, we pass the steam through the low pressure turbines, the rotors rotate, and then the steam has effectively fulfilled its purpose. It's given up a lot of heat, and the best thing for us to do now is to cool the steam, condense it, pump it back through a heater to the deaerator, and then back to the boiler again. So those are our water and steam circuits. So we've
Okay, so just to give you some idea about what's happening in these main components in a steam power plant or thermal power plants. It's very nice, this virtual tour. Now, let us investigate some actual, yes, Sajjad.
Sir, what is the reason first the steam enter the high pressure turbine, then enter the low pressure turbine? Why they do this? Can explain about this?
Thank you for your question. Who can answer that? So Sajjad is asking why first it's going to the high pressure turbine. Why not to the low pressure turbine? Is that correct, Sajjad? So you're saying why it's not going to the low pressure first? Okay. Who can answer the question? Yes, Joy.
Initially, when steam is created inside the boiler, it is almost 80 bars. This is the highest the highest pressure steam generated. So since this is the highest pressure steam, so it should first go to the high pressure turbine. It shouldn't go to the low pressure turbine.
Thank you for your answer point. Now, Sajjad, try to understand always when you have a process, what happens to the pressure? Does it increase? So if it goes to the low pressure first, then how the pressure will increase later on? And again, it will go to the intermediate pressure or high pressure. How it will happen? Sajjad. I'm just wondering why you are thinking in that direction. I mean, I'm trying to understand that. Yeah. I mean, why you are thinking that first? I mean, what's the way something will go from low pressure to high pressure? What's the way? If you want to increase pressure, you will have to do something, right? You'll have to do something. You'll have to use, let's say, if it's liquid, you'll have to use pump. If it is gaseous, then you'll have to use a compressor. Yeah. So from low pressure to high pressure, how you will gain the pressure? You want to add another device, a compressor or something?
Yes, sir. Yes, sir. It's
no,
needed.
that's not that. No, I mean, you cannot do that. That will, I mean, decrease the efficiency. And compressors are more energy intensive than pump. So pressure always goes from high to low, high to low.
Yes, sir.
Yeah, you can consider it as a voltage. Yeah, you cannot go from low voltage to high voltage. Are you getting the point?
Yes.
Anyway, I'll give you a point. I give you a point for your curiosity and for your question. Anyway, so actual thermal power plants, what you have? Actual thermal power plants has the features of reheating. That means you have multiple turbines. Yeah, you have the features of reheating. And also regeneration. Reheating and regeneration, both of these are there in the modern thermal power plants. The combination of those, and also you have extra many more equipment due to many reasons, like to increase efficiency, to make, to lower the emission, things like that. So they are much more complicated. So I'll try to show you the schematic diagrams of 300 megawatt, 500 megawatt, and 1000 megawatt units, so that you understand in reality what you have. So here in this boiler, this is a 300 megawatt power plant. You can, by the way, you can download this article, Wang et al. 2020. It's an open source software. You can download this from this link. URL is given. You can download this. It has CC BY license, so that's why I'm using it with attribution. So here you can see. Let me see how you can interpret things. Yeah. So this is your boiler. Yeah. You are supplying air and fuel, and then in the boiler, as you know, first it's going eco. What do you think? What is this eco? What is this eco thing? Yeah, Akhtar.
Economizer.
Economizer. Okay, then SH1 or something. SH. What is this SH thing? Jannat.
Superheater.
Superheater. Then there is RHR or something like this. RH is written. What is this? Tubing arrangement inside the boiler. Nabil.
Feed water heater.
RH. Nabil. Sajjad.
Sir, reheat.
Reheaters. Reheaters, you can understand very clearly. See, after the high pressure turbine, it's coming and going to this RH thing. Yeah, reheaters. And you have, as I said, in reality, in modern day power plants, you have high pressure turbine, intermediate pressure turbine, and low pressure turbine. Okay. Then you have different valves. You can, some of this. Okay, here you can see there are a few things here. RH. They have numbers, different numbers, by the way. Anyway, what are these things? These things. What are these things? Sanwar.
Sir, reheater pump.
Reheater pumps. No, Sanwar. Sajjad. I can't hear you. Rausin.
Sir, deaerator.
This is deaerator, by the way. This is deaerator. Yeah, it's open type feed water heater. But I am asking you about this. There are 6 units. What are these 6 units? Farzin.
Sir, reheaters which happen in multiple stages. The reheating process.
No. This is not reheater. Sanwar.
Sir, regenerative heater.
Regenerative heater, they are known as feed water heaters. They are regenerative heater, feed water heaters. Feed water heaters. Yeah. And what do you think? What's the type? They're closed type, open type. What is the type here? Fine.
Sir, closed type.
Closed type. These are closed type. So in this power plant, how many closed type feed water heaters are there? Sajjad?
Sir, 5.
No. Mubashir?
Sir, 6 type.
6.
Sir, 6.
6. These are the 6
Yes, sir.
feed water heaters, closed type. 1, 2, 3, 4, 5, 6. These are 6 closed feed water heaters. And there is one open type, which is your deaerator, which you saw in your schematic diagram from Senjel. Okay. So this is really the thing. And this is, what is this thing? What is this thing? Asif. What is this thing? Asif, no idea. Afia.
Sir, condenser.
Condenser, obviously. Obviously condenser attached with the low pressure turbine. What is this thing? This thing. This one. Okay. Shubho.
Generator.
This is generator. This is just a generator coupled with the shaft of the turbines. All the turbines are in a single shaft. It's connected with the generator. Okay. So this is just to show you how does it look, the actual power plant cycles. And here you can see the operating condition. Operating condition. So the mean steam temperature in this case is 538 degrees centigrade at full load, 100% load, and 75%. Even then, it's same. Main steam pressure, MPa, 16.67. This is 300 megawatt power plant. But at part load, let's say when it's 75%, then it's 13.25. Main steam flow rate, kg per second, 260. Reheated steam temperature, 538. So it's same like the main steam temperature, 538. So it's same. Remember, T1, T3 equal to T5. In this case, 538. Then reheated steam pressure, 3.38. We solved the problem. In that problem, what was the intermediate pressure? I mean, the pressure for reheating. We solved the problem. Who can recall? There was one intermediate pressure. Yes, Akhtar.
So 10 megapascal.
No, 10 megapascal was basically the main steam pressure. What was the pressure for reheating, Shubho?
So 3 megapascal.
3 megapascal. And now see, in reality, in this 300 megawatt, it's 3.3. It's close. It's close. You should have a feeling, as a mechanical engineer, you should have a feeling about this important parameters. Yeah. So these are some of the things, I mean, parameters I wanted to discuss with you. Also here, the feed water temperature. See, feed water temperature, then feed water pressure, all these things are there. Feed water pressure is 16.7. And the flow rate is 260, 16.7. Yeah, 16.67, 16.77. So a little bit higher than the main steam pressure. Of course, it has to be like that. Yeah. So the feed water pump is maintaining tremendous pressure here. Now, a 500 megawatt unit. In this case, again, you are seeing those same things here. So, from one power plant to another, they might be drawing the schematic diagram in a different ways. So in this case, they have drawn it in a little bit different way. Yeah, they have started, the boiler is located on the left-hand side or right-hand side. In this case, where is the boiler? There is no clear cut. I mean, it's not shown. Suppose you are visiting a power plant, they are giving you, this is the schematic diagram. How you'll interpret, Ahmed Adnan? Where is the boiler?
It's the left-hand side.
Left-hand side. Actually, they have not shown explicitly with the outer structure, but these are the things here. The RH. Something is written here, RH. What is this RH? What is this RH? Mubashir.
Reheater.
This is reheater. Eco. Something is written eco. What is this eco, Arnob?
Sir, economizer.
Economizer. And this is your main boiler drum. Yeah, boiler. And okay, let me ask you again. What are these things here? This is a 500 megawatt power plant. What are these things here? Here it's written deaerator, clear cut, deaerator. But what are these things? Safayat.
Sir, feed.
Sorry?
Feed pump?
No, not feed pump. Mutasim.
Sir, feed water heater.
Feed water heaters.
Yes, sir.
What is the type, Tanjid? Open or closed?
Sir, closed, sir.
Closed type. So how many closed type heaters we have here? Yeah, Asif.
Sir, 6.
Asif, how many closed
7.
type? 7. 7. 1, 2, 3, 4. Okay. What about this one? This is your deaerator. 1, 2, 3, 4, 5, 6, 7. There are 7 closed type feed water heater. Yeah. And this is deaerator. You're seeing these are typical things, by the way. Yeah. So again, you are seeing another 500 megawatt ones. Now, again, you can see the operating condition, the pressure here, 2 to 6, the unit is different. Yeah, and unit is kg per centimeter square, not MPa. It's given in kg per centimeter square in this case. Yeah, the temperature is a little bit less than 540 degrees centigrade, and they have taken it from different sources, by the way. Yeah, for a 500 megawatt power plant, they tried to collect models from different places, different sources. I can identify GE, General Electric, Hitachi, some of this. So basically, if you want to know more, visit this, go to the link, and you can get details. I don't have time to cover all the nitty-gritties, but here you can see there is a comparison of the operating, I mean, the 4 different types of technologies, coal-fired power plants: subcritical, supercritical, ultra supercritical, and advanced ultra supercritical. There are 4 types. Yeah, of course, when you have advanced ultra supercritical, see, the pressure is highest, obviously, 255 to 357 kg per centimeter square. And look at the temperature. Temperature is between 700 to 725. Much higher. When it's ultra supercritical, the temperature range is between 580 to 620. Now, of course, the boiler must supply the steam at this high temperature and pressure. But what will be the consequence when you have this kind of high temperature, like 700 degrees centigrade? What is the consequence for turbine at that very high temperature? Is there any consequence, or is there any factor we'll have to consider, Ibrar?
Sir, possibilities of element or material failure or material degradation.
Melt, yeah. If they, they might melt.
Yes,
Normal
sir.
materials will simply melt. So you have metallurgical challenge. The turbine blades must withstand this kind of pressure and temperature, this kind of high pressure and temperature. I saw from IHI, one of the manufacturers of boilers from Japan, now they are using nickel-based alloys, and to withstand that kind of high temperature and pressure. So you need special materials to withstand that high pressure and temperature. So this slide is giving you a comparative thing between subcritical, supercritical, ultra supercritical, and advanced. This is very important slide for you. I'm requesting all of you to pay attention in this slide and see how they vary from subcritical to supercritical. Now in Bangladesh, of course, in Matarbari, I told you, they are using ultra supercritical. Advanced ultra supercritical is coming up. That's the technology of the, I think they will come up in the future, near future. GE has already started. The efficiency is highest in this case. Yeah. And also you can see this supercritical pressure coal-fired power plant. When it's 500 megawatt, it's usually supercritical pressure coal-fired power plant. Then you can see the parameters, what you have. Yeah. Let us focus on this temperature. Yeah, in this case, the temperature is 566. Yeah, reheat temperature is 593. So it's not the same like your main steam temperature. So your T3, usually T3, if you recall the figure you saw earlier for reheat power plant, T3 is usually, we think that they are equal, but in this case, they are not equal. T5 is larger than T3. In this case, you can see it here. Yeah. So I just want you to get a feeling of how what are the values of different parameters in actual power plants. That's the reason for showing all these slides. Okay, now that's the last unit I want to discuss. 1000 megawatt unit, and here, yes, this is ultra supercritical. This is ultra supercritical power plant. And in this case, how many closed type feed water heaters you have? How many? Farzin?
Sir, 2.
2. Yeah. In this case, you see they are written as LP feed water heater and HP feed water heater. Low pressure feed water heater and high pressure feed water heater. In the case of low LP feed water heater, the steam is coming from LP type turbine, low pressure turbine. In the case of HP feed water heater, the steam is extracted from the IP turbine. For deaerator, steam is extracted from the IP turbine. It's written clearly here. Written clearly here. Okay. So just to show you, this is 1000 megawatt power plant. You can again get more details. Due to time crunch, I cannot go into details. You can visit this link and download the article and study it. Now, case studies for Bangladesh. I mean, this is an excellent presentation. I shared this already with you. One of my former colleagues from BPDB. Now he's one of the chief engineers, but previously he was a director at the coal power generation company or something like that. And they were responsible for Matarbari power plant. He delivered a nice presentation. It's available on YouTube. I have shared the link with you. You can watch that to gain more ideas about different power plants in Bangladesh. So let me show you the few things from the slides of Mr. Obaidullah. Actually, he used these slides during his presentation. Just let me show you from his slides. So in Bangladesh, we have this Boropukuria. This is the first one. Boropukuria is the first one. First coal-fired power plants in Bangladesh. And it was mine mouth. So the power plant was located just near the mining site. Yeah, Boropukuria. Then we have other power plants like Rampal near Sundarban area, Paira, Bashkhali, Matarbari, also at Maheshkhali. So seven, right? Now, let me show you something from the Matarbari, their schematic diagram. This is the schematic diagram of Matarbari. And this is USC type coal-fired power plant. USC. What is USC? Who can tell me? USC. Who can tell me what's the meaning of this acronym? Sadman.
Sir, ultra supercritical.
Ultra supercritical. So the technology is ultra supercritical. Not only that, there is another advantageous feature. The boiler with low NOx burners. This is awesome. You know, we have the issue of NOx emission from this coal-fired power plant. So the boiler is specially designed to have low NOx. So the burners are special, basically. Low NOx burners are there. Yeah. And then you have other things. Yeah, these reheaters and other stuff which you can see here. So it's quite useful. Later on, I mean, the slides are shared with you. I want to request you to go through this site. So he discussed in his video about Rampal and Paira and all those power plants. Now, let me show you another thing. What's the situation of these power plants now? What's their situation? Yeah, let us investigate that. I downloaded the generation report from PGCB's website today before the class. But the generation, what you're seeing is for 11th December, so day before yesterday, right? So let us see how these coal-fired power plants performed day before yesterday. Yeah. So SS Power, I don't know. This maybe the Shaji Bazar one or something. I don't know exactly which one they meant by SS. And the capacity is 612. There are 2 units based on coal. What is written here? Somebody was telling you abundance of coal. What is written here? Here. Yeah. Can you see? Can you read? Yes, Rausin.
Sir, coal shortage.
Coal shortage. Yeah. So actual generation was rather, the capacity is 1224, day peak time 455, evening peak time 490. Yeah. So you can understand the situation. Matarbari, it's currently on test. Currently, it's on test. Yeah. So it gave some values. Yeah, 565 or 575, something like that. Yeah. Okay. Now let us see some other ones, other coal-fired power plants. Yeah, Rampal, 1320 megawatt. Yeah, there are two 660 megawatt units. How much it generated day before yesterday? How much? Can anybody tell me?
Zero, sir.
Zero. So what's the consequence when you have a expensive power plant like this and sitting idle, not generating anything? What's the consequence? You studied that in the economics of power plant. Well, what's the consequence? What's the consequence? Consequence is the capacity factor will be low. The cost of energy will be high from this power plant. Isn't it?
Yes, sir.
Then Pyra, 1320. There are two 622 megawatt units. Yeah, it gave some power, but not 1320. It delivered around during peak hour 622 megawatt. And what is written here? What is the remarks?
Under maintenance.
Yes, under maintenance. The first unit. Is it a very old power plant, this Pyra? Is it very old?
No, sir.
No, sir.
And the Borishal, 307 megawatt. Yeah, yeah. What is written here?
Coal
Sir,
shortage.
coal shortage.
Coal
Coal
shortage.
shortage. Now from this you can see what's happening. And the Adani Power, that's also coal based. Yeah, we are importing, and it's even that one is not giving the whole capacity, by the way, giving I think half of what we are supposed to get. What about Borupukuria, the first one owned by BPDB even? The first two units 125 megawatts, the third unit is 275 megawatt. What is the situation here right now? How much we are getting from Borupukuria right now?
Sir,
The first two units, nothing. First two
85.
units are under maintenance. They are under. Third unit gave, instead of 274, it delivered 170 megawatt. So just to show you what's the situation of the coal-fired power plant in Bangladesh. Yeah, I think, are you getting the point? I mean, how they're performing these power plants? I mean, are you getting the dismal picture? Yeah, of the power sector.
yes, sir.
Yeah. So these are from PGCB, Power Grid Company of Bangladesh, is maintaining this generation report. This is from there, by the way. Okay. Selected commercial products. So I have compiled some links for you. And these are some of the reputed companies: GE, Mitsubishi, Kawasaki, IHI, Toshiba. From there, you can gain more information about some of the commercial boilers. And also, I've given you some links regarding steam turbines from AC, GE, Siemens, Mitsubishi, Kawasaki, even Toshiba. They manufacture steam turbines. You can visit their websites. Yeah, so I think you'll benefit. Now, emerging technologies. I'll stop with this. So emerging technologies. So in the coming days, Fairuz, you have any question? Okay, high efficiency, low emission technologies are there, and you can get more information from IEA, International Energy Agency's document. And what they are suggesting that you can have integrated gasification combined cycle in the future, carbon capture and sequestration, CCS, advanced ultra supercritical thermal power plants, which will have higher efficiency, circulating fluidized bed combustion, integrated gasification fuel cell, and all this. And also IHI is coming up with this ammonia fired boiler, so which doesn't have any greenhouse gas emission. So these are some of the emerging technologies which are expected to show up in the future and more. Anyway, today I showed you an animated animation which showed a typical thermal power plant. Then we investigated 3 types of actual thermal power plants with different capacities: 300 megawatt, 500 megawatt, and 1000 megawatt. And also in our case studies, we discussed some of the power plants in Bangladesh, how they are performing. I suggested few commercial products for boilers and steam turbines, and tried to very briefly show you some of the emerging technologies based on IAEA's report, International Energy Agency's report. So with this, I would like to end today's class session. Thank you very much.